Okay, guys, we are doing conditional probability on day 2. We're actually only going to get through one example today, and that's all right. Taking it a bit slow since we're doing this online. So example 4, for ACL reconstructive surgery, the probability that the surgery is successful is 90 or 0.95 or 95%. Find the probability that 3 ACL surgeries are successful. They're independent of each other, right? I mean, if I have ACL surgery, then you have ACL surgery, and then another person, they're independent of each other. My success does not depend on your success, does not depend on another person's success. So because they're independent, you are literally just going to take the probability of success and multiply it by itself 3 times, right? Because here's the first one, here's the second one, and then here's the third one. I guess I could have done 1, 2, 3 instead of arrow, arrow, arrow. But you just multiply it by itself. And then that probability, and I think I wrote out all the decimals. So 0.857375. So if you only have one, you have there's a 95% chance of success. But when you have let's say 3 in a row or whatever, it drops down to roughly 85%. But that's still pretty darn good. All right, find the probability that none of the 3 ACL surgeries are successful. So if 0.95 are successful, 1 minus 0.95 or 0.05 are not successful, right? That's the complement. That's how we find the complement of something. We do 1 minus that probability. So what you're doing, and again, these are independent of each other. So probability of no success on the first one, probability of no success on the second, and then probability of no success on the third. You just multiply those 3 out. So let me just double check, 0, 0, 0, 1, 2, 5. Okay. All right. Find the probability that at least one of the 3 ACL surgeries is successful. When you do this, to find that probability, it's a little, and there's a sentence that's going to sum it up at the end of the notes. At least one is going to be 1, meaning 100%, minus the probability that none of the 3 are successful. Because at least 1 is the complement of none of them being successful. So all you're going to do is 1 minus, and then that's that lovely decimal 0.000125. And so the probability that at least one of those is successful is 0.999875. Okay? What do we got next? Rotator cuff surgery. Apparently we're just doing surgeries. So it's the same kind of thing. Find the probability that... Well, I think I did that in red first. Not that it matters. Find the probability that the 3 rotator cuff surgeries are successful. Again, you have a 0.9 probability for success. So 0.9 for the first times 0.9 for the second times 0.9 for the third, right? Because they are all independent of each other. So it is 0.729. Okay. And then again, find the probability that none, right? Remember, 1 minus 0.9 that are successful means 0.1 are not successful. Or it's the probability that it will not be successful. And so all you're going to do is 0.1 times 0.1 times 0.1 will give me 0.001. And then, of course, we have this lovely at least one of the 3. So remember, you're just going to do 1 minus probability that none are successful. Or none of the 3 are successful. Okay. I think I spelled successful wrong. I don't know. Did I? It looks weird. Sorry. Again, you're looking for the complement of this is basically what you're looking for. So it's 1 minus 0.001, which is 0.999. Okay. And then here's that last sentence that kind of sums it up. So when you're finding the probability of at least one, it's easier to find the probability of its complement, none, right? And then subtract it from 1. So this is what we did for part C of those last two equations. Nope, 2 examples. Sorry about that.